from this video, we're going to take the final step. So let's do it. So as I explained in the last video, we're going to get MGF of S, which is the scaled value of sample mean. It'll be like this. So let's get MGF of S. So which would be described as ST, right? As we saw. And if we put the definition of S here, it's going to be something like this. So if we put this here, like to make it more easier to see, clear to see, it would be like this, and X bar, mu, and T. Everything clear, right? We can keep moving on, and we can actually expand this sample mean as the sum of X divided by number of the sample. So it's going to be like this, and x1, x2 until we see xn, and divide it by the number of the sample, and minus mu times t. It's the same. And we don't want to again remove this n because it's kind of irritating to see that. So what we're going to do is just let the sum of each element inside, the variable of each element of the sample to be there by themselves, and like this, and put n out. So it's going to be, when it goes in, it's going to be like this, and so it's going to be like this. So it's exactly the same form. So times t. Perfect. And we can calculate this here. So it's going to be square root n here. So, okay, everything clear here. And we know that x, which is the variable of each element of sample, it follows because it's one sampling, as I explained in the previous video. It follows the distribution of sample, like mean and like this. So it's confusing whether it's like sample or a population, but as explained in the previous video, if we take one sample out of population, that one sample follows the exact distribution of population. So yeah, it's confusing. So it's highly recommended to review the previous videos. So it follows the population, and population follows normal distribution. So we want to distribute this n number of mu into each area here. So what we want to do, because we're going to do scaling, to make scaling form like this, So to make the form, let's put this here together. So it'll be like this, and distribute each mu into each part like this, because there's n number of element, and it's also n number of mu here because there's a minus in front of it. So like this until we meet the last element, and oh, there's no space anymore. So let me only write down like this, and times t. Oh, and we wanted to make this form, so we needed the standard deviation of population. But fortunately there's one perfect form here, so we can just use that. So it's going to be, let's take t into here so that we can see more clearly, like this, and it's going to be inside or like this. Sorry. And until we face the last element here, like this. It's a little uncomfortable to see. Okay, like this. Oh, sorry, I think it's not supposed to be here. It's supposed to be here. So we can divide it into each part like this, and like this until we face the last element. And we know that here each element in the sample, even though they represent the population, but still they're sample, right? The meaning that they're exactly the same value, I mean exactly the same, like has the same implication that is same as population distribution, doesn't mean that they're not samples. They're still samples, but samples that has the same implication with population distribution. So they're still sample element, and we know that each element were picked independently when we did the sampling. So we know that also this part and this part and so on are independent to each other, because all the others are constant in this expectation form. So as we studied in the many videos ago, which was the multiplication of expectation, because we know that each element inside are independent to each other, we can divide it into each part like this. Times t, like this, until we get the final one. N, right? Sorry. Like this. And we know that each variable just represent the population variable, because again they're one sampling result. So we can say all the result here represent the same value. So it's going to be just like this. Let's just say x as a representation of population variable like this, and we can tell that there's n number of this form here because they're all same. Yeah, so this is the first step of this process. So let's keep talking about the next step in the next video.